Hello everybody, I am Professor Dr.V.K. Gupta from Scope Global Skills University, Bhopal. Dear friend, today we will discuss the extreme values of a function. Firstly, let us know what is extreme values. Here, I am explaining in short what is extreme values. It means the guarantee of a function which gives maximum as well as minimum value in particular interval. Like that, let us consider in xy plane any function y is equal to f x and its representation in interval x1 and x2 is like this. Here you can observe that between the interval x1 and x2, this function y is equal to f x attains some different type of point in upward direction a, b and c, whereas in lower side you can say a dash and b dash. These points a, b, c represents the maximum and a dash, b dash represents minimum. Now, it is the matter to discuss how will analyze whether these points are maximum or minimum. For this, let us consider we have any function y is equal to f x and our aim is to find the maximum value of function or minimum value of function, that means extreme values of the function. I am explaining this method in steps. First of all, write given function and after that find its first derivative, that means the differentiation of this function with respect to its independent variable x, which also may be represented as f dash x. This is step number 1, and impose on the necessary and sufficient condition for existence of maxima or minima. Remember this thing, this is necessary and sufficient condition for existence of maxima or minima in any particular interval, inside any particular interval for any function. This is first derivative of the function must be 0. If we apply this condition, then we get an equation in terms of x. Now, we will solve this equation f dash x, which is equal to 0 for different values of x. Suppose those values of x are a, b, c and others. After that, getting these values of x, remember one thing, these values of x are also known as critical point or also known as stationary point. After getting the values of x, we will find out second derivative of the function, that means d2y by dx2, which is also represented as f double dash x, and now choose any one value of x, say x is equal to a, out of all those values which we had obtained in step number 2 when we had solved f dash x is equal to 0, and we will find out the value of second derivative at this particular point x is equal to a. That means second derivative f double dash x at x is equal to a, which is f double dash a, and on the basis of value of second derivative at our chosen point x is equal to a, which may be 3 type of the values, either it is 0 or greater than 0 or less than 0. If this value of second derivative is greater than 0, we conclude कि function has a minima at x is equal to a. And if this value is negative or less than 0, then we conclude कि function has a maxima at that point x is equal to a. But if this value is equal to 0, then it is necessary to find or to apply the further investigation. Now, for this, let us consider the same working for the same function. That means, we will find out next order derivative, that means third order derivative, d3y by dx3. This is when our second derivative at any particular point becomes 0. I am repeating again, in this condition we will apply the second derivative, we will find out the next derivative and next order derivative and check whether it is not equal to 0 or it is equal to 0. If it is not equal to 0, then finally we conclude कि function has neither a maxima or nor a minima, but not everywhere, only at that particular point x is equal to a. And if it is 0, then again go ahead for higher order derivative, that means find fourth derivative of the function and basis of value of this fourth derivative at that particular point x is equal to a, examine the nature of function similarly as second derivative check. That means, if it is greater than 0 or it may be equal to 0 or less than 0, means positive or 0 or negative, function has maxima. In case of negative, function has maxima. In case of positive value, function has minima, and here again required higher order test. So, in short, we conclude this discussion as function can attain any value, maxima or minima, whenever we apply the condition its derivative or its first order derivative becomes 0, it gives different values of x, may be a, b, c and others. These are critical point or stationary point, and after getting these stationary point or critical point, we will find out its second order derivative and calculate the value of the second order differentiation of the function at any chosen point x. If this is 0 or less than 0 or greater than 0, according to the test, we will decide whether the function has maxima or minima. Next thing, here I am using the word maxima, but remember, not maximum. Another is minima, but not minimum. There, where x is equal to a, if we find कि function has a maxima point, then substitute this value at given function f of x, and f of x at that value x is equal to a, the value of A is the maximum value, whereas in case of this f(x), f of A has a minimum value if given function have a minimum point at x is equal to A. According to that, we will decide the maximum value as well as minimum value of the function. I think it is very much clear to you. In next lecture, we will illustrate any example on the basis of this method. Thank you.